हम लोगों ने अपनी शुरू करनी है जी एनालिटिकल केमिस्ट्री। ठीक है जी। सो लेट्स स्टार्ट विद द एनालिटिकल केमिस्ट्री। Okay, my dear. So with the analytical chemistry, you people should know about the first topic we are going to start. That is uh, the NMR and mass spectrometry. So these two topics they are joined with each other. Okay. So we should learn these topics side by side. Okay. So let's start with the NMR first of all and mass spectrometry. I'm telling you about the introduction about how what is the advantage of the mass spectrometry and what is the advantage of the NMR. Okay, so let's start with it. First of all, mass spectrometry. Mass spectrometry is a technique which will give you the empirical and the molecular formula of a compound. Okay. Uh, so mass spectrometry, it helps us to find out the empirical and molecular formula of compounds. Okay, so this is the first thing. Let's suppose, my dear, the molecular formula of a compound that is C3H6O. Okay, so this is the molecular formula. Now, this molecular formula is the molecular formula of which structure? Because this formula could have the structure this one, CH3, CH2, C double bond O, and H. So this is the propanol. It's an aldehyde. Okay. If you count 1, 2, 3, 3 carbon, hydrogen 3, 2, 5, and 1, 6, and oxygen is 1. Okay. This formula could be CH3, C double bond O, and CH3. So this is propane 2-on. So this is, my dear students, the ketone. So this formula could be having this structure. And the last one, CH2 double bond CH, CH2, and OH. Okay, so this is the alcohol. The name of this alcohol, that is propinol. Okay, so this is the alcohol. It is having the double bond as well as the OH group in it. Okay, so these three structures, they are having the same molecular formula. So mass spectrometry only gives you the molecular formula, that what is the molecular formula of that compound. Okay, whereas the NMR is a technique which is used to elucidate the structure of the complex organic molecule. That what could be the structure, whether this is the structure of this molecule, or whether this is the structure of this molecule, or this is the structure of this molecule. Okay, so the molecular formulas of which structure? Okay, so this NMR technique is used to find out the structure of the organic molecule. Okay, so it helps us to elucidate the structure of complex organic molecules. Okay, so we got these two spectrometry. The first one is mass spectrometry. The second one, that is NMR spectrometry. Its full name is NMR spectrometry. Okay, so these are the two techniques. One of them is helps us to find out the molecular formula of the compound. The second technique tells us that what is the structure of that molecule. Okay. Now we are going to start with the details of these NMR spectrometer. First of all, NMR word that is made up of nuclear, M for magnetic, and the R word means resonance. Okay, so nuclear magnetic resonance. So this is the first thing. The second thing, okay, guys, the NMR that is of two kinds. The first one, that is the hydrogen NMR, and the second one, that is the carbon 13 NMR. Okay, so you got the two different kinds of the NMR, hydrogen NMR and carbon 13 NMR. Now, if you look at these two NMR technologies, so this one and this one, both are having the nucleon number that is odd. Okay, so you got odd number of the nucleons, odd. These are the odd numbers. So keep in the paper, he has asked this question many times. For which elements the NMR technology, NMR spectrometry could be used. So keep remember, NMR spectrometry could only be used for those elements which have odd number of nucleons in their nucleus. The number of protons and neutrons, that is odd number. So carbon 13, it got odd number of nucleons, protons and neutrons, 6 protons and 7 neutrons. Whereas in the hydrogen, it got only 1 proton, no neutron is present, so it is also the odd number. Okay, so just write it down. NMR spectrometry could only be done for those elements having odd number of nucleons. Okay, odd number of nucleons. Nucleons word mean the number of proton plus neutron. Okay. Okay, my dear. So now we are going to start. This is actually the introduction of NMR. That what is actually the NMR? NMR is used to find out the structure of the complex organic molecule. The first thing, it has got the two types, hydrogen and the carbon 13 NMR. Okay, so it means this technique would only be used for those elements which are having odd number of neutrons. Now we are going to start with the hydrogen NMR. Okay, so let's start with the hydrogen NMR. Okay. Uh, Now just listen it, my dear. First of all, I'm going to talk about the hydrogen nucleus. Any one of you could tell me the nucleus of any atom is stationary or is it moving? Nucleus? Nucleus. Stationary. Very good. What do you think, Adam? Muskan?
Sir, what is the question, sir?
My question is, what you think about the nucleus of nucleus of an atom? Is it moving or stationary?
Sir, I think it's in vibrational motion.
Vibrational motion. Okay. Muskan, what you think, beta? I'm just asking your guess. I'm not asking the accurate thing. Then I'm gonna tell you about it. Stationary. Uzair, what do you think, beta?
सर
Uzair,
जी मेरे ख्याल स्टेशनरी होता है.
stationary. Okay, that's fine. Okay, guys. Now keep this thing in your mind all the time that the nucleus of any atom that is not stationary. It is always revolving or rotating, whatever you say. Anything which is revolving around its axis, this word is called revolving or rotating. Rotating. So rotation is like that. Okay, it is rotating or revolving around its axis. Okay, so the rotation that could be clockwise, okay, or anti-clockwise, like that. So it could move. Have a look up here. This one is moving like clockwise direction, clockwise, or it could move like anti-clockwise direction. So the nucleus of any atom is not stationary. It's always revolving around its axis. Okay. Now you know that hydrogen got only one proton and proton got the positive charge. So when the nucleus that is rotating, it means positive charge that is moving, that is rotating. And you know that whenever there is the movement of any charges, the current that could be produced. Okay, and when there is a current, okay, so there is a magnetic field which is produced. Okay, so its direction could be find out by Fleming's right hand rule. Okay, so what should you do? You should curl your fingers like that. And so if you curl your fingers in an anti-clockwise direction, okay, this is anti-clockwise. So the thumb direction is upward. So it means the magnetic field produced that is upward. So it is anti-clockwise. Okay, magnetic field is produced upward. And if the rotation of the nucleus that is clockwise, okay, clockwise direction. This is clockwise direction. So clockwise, you should rotate your fingers like that. The thumb is moving downward. So the direction of the magnetic field that is downward. Okay, so you people got the two types uh, of the spin states in case of hydrogen, that is clockwise and anti-clockwise, due to which magnetic field is either produced upward or downward. So in clockwise, did you get it? Downwards. Okay, my dear students, so these two, it means hydrogen, they act as a tiny magnet. Okay, so these two tiny magnets, they do not attract or repel each other. Okay, but if you apply the external magnetic field, let's suppose, okay, my dear students, now what I'm going to do, hydrogen, if you apply the external magnetic field in the form of electromagnet or in the form of permanent magnet. So this is the external magnetic field. External magnetic field. Okay, so when the two magnets they come close together, either they are going to repel each other or they are going to attract each other. So now keep remember those spin states whose magnetic field aligns the external magnetic field, they are having the forces of attraction, so they would come at low energy level like that. Okay, whereas those spin states whose magnetic field that is reverse, of that external magnetic field, they would repel each other, so they are present at high energy level, like that. Okay, so now the hydrogen atoms, they form the two spin states, the two different energy level, and this energy difference, that is delta E, and it could be increased or decreased by changing the strength of the external magnetic field. If you increase the strength of the magnetic field, so this one would increase, and if you decrease the strength of the magnetic field, that would be reduced. Did you get it? So I have told you the two things right now, that hydrogen, they have two spin states, clockwise and anti-clockwise, due to which magnetic field is either produced upward or downward. So this is clockwise and this is anti-clockwise. Okay. So in the absence of any external magnetic field, the two spin states, they do not attract or repel each other. They are present at same energy level. But as soon as you apply the external magnetic field, the two spin states, they adjust themselves at two different energy levels. Those spin states whose magnetic field aligns the external magnetic field, they would be at low energy level. And those spin states whose magnetic field is reverse or opposite to that of the external magnetic field, they would be at high energy level, and the difference of energy level between those two spin states, that is delta E, and delta E could be increased or decreased, okay, by changing the strength of the external magnetic field. Okay, so this, let's suppose this delta E value, that is 498 joule. I'm just going to suppose it. Okay, it's not the any accurate value. I'm just going to suppose it. 498 joule. Now this range of the delta E, that comes in the range of radio waves. So what we do, we throw the radio waves from here. Okay. So these radio waves, they passes from here, okay, and there is a detector. So this is the detector present up here. Let's suppose to simplify. सर बिल्कुल बनाना है, ये काफी मुश्किल है, मैं बहुत आसान तरीके से आपको समझा रहा हूँ, बुक से पढ़ोगे ना तो ऊपर से गुजर जाएगा। अच्छा जी, just listen guys. Let's suppose this is the radio wave oscillator. This is going to produce the radio waves. From here, the radio waves, 100 radio waves, they are produced. And detector receive the 100 radio waves. So there is no detection. But if this one produce 100 radio waves and 80 radio waves, they reach to the detector. So this detector is going to detect something and will note it in the form of some peaks and results. Okay, we will discuss those peaks later on. But anyhow, what happens to those radio waves? So those radio waves whose energy is exactly equal to delta E, exactly. It's not like that one of the radio wave, it is having 500 joule of energy that would be absorbed. No, any radio wave who's having 498 joule energy exactly. So that radio wave would be absorbed by the spin states at low energy level. So what they do after absorbing the energy, firstly, they are rotating like that, suppose. So when they absorb the energy, their rotation that would be reversed, and their magnetic field that would also be reversed, and they jump at high energy level like that. Right. And this process, that is called as the resonance or flip over. Did you get it, guys?
Yes, sir.
Okay, now I'm going to dictate you these points. So please just write down these points. The first point, hydrogen has two spin states. Hydrogen has two spin states. Two spin states. TWO. Two spin states. Okay. clockwise and anti-clockwise. Clockwise and anti-clockwise, due to which magnetic field is either produced, upward or downward. Write the second point. The two spin states do not attract or repel each other. Write the third point. When we apply the external magnetic field, the two spin states arrange themselves at two different energy levels. Those spin states, continue this one. Those spin states whose magnetic field aligns the external magnetic field will be at low energy level due to forces of attractions. Will be at low energy level due to forces of attractions, whereas the others would be at high energy level. Whereas the others would be at high energy level due to forces of repulsions. Write the next point. The difference of energy between two spin states. Is delta E and comes in the range of radio waves. Write the next point. Those radio waves whose magnetic field, whose energy is exactly equal to delta E will be absorbed by the spin states at low energy level. They change their spin and their magnetic field would be reversed.
Sir, absorbed by the spin states at lower energy level. उसके बाद sir,
बेटा पता नहीं मैंने अब क्या लिखवाया है क्योंकि मैं अपनी तरफ से लिखवा रहा हूं. They change their spin state, their magnetic field will be reversed and they jump at higher energy level, and this process is called resonance of flip over. Okay,